The worst earthquake to hit Morocco in at least 120 years was a strong magnitude 6.8 quake that occurred Friday night. More than 2,100 deaths have been reported, and according to officials, the number will continue to grow as rescuers make their way to the affected isolated, mountainous districts. According to the US Geological Survey, the Mediterranean region is seismically active, even if such powerful earthquakes are seldom in North Africa. The most recent earthquake in Morocco was caused by a phenomenon known as a reverse fault, in which tectonic plates progressively collide and thicken the Earth's crust. The stress from the collision then abruptly releases in the form of an earthquake. Few buildings in the area are built to withstand earthquakes because they are rare, and locals have little experience responding to quakes when they do happen. Large-scale damage was done to numerous centuries-old Moroccan structures. In areas that are prone to earthquakes, however, they can still be deadly. During the first hour of Monday in February, a powerful 7.8 magnitude earthquake shook Turkey and Syria. Several hours later, a second 7.7 magnitude earthquake shook the area. In the area, more than 6,600 buildings were destroyed, and more than 50,000 people were killed by the earthquakes. Turkey is traversed by two significant fault lines, which frequently produce shocks. Less frequently occurring but nonetheless commonplace are larger quakes. Turkey had a magnitude 5.9 earthquake in November of last year. In 2020, an earthquake with a magnitude of 7.0 shook the Aegean Sea between Greece and Turkey. Forecasting when an earthquake will occur is still impossible, despite the fact that scientists' knowledge of the likely locations of earthquakes has greatly improved. People might easily be caught off guard by the Earth's rumbling, which worsens the subsequent death and destruction. Here is a brief overview of earthquakes in light of the recent catastrophes, along with some of the most recent research on monitoring and forecasting them. Why do earthquakes happen? When massive fragments of the Earth's crust abruptly move past one another, an earthquake is caused. The Earth's mantle, a layer that over millions of years behaves like a very slow-moving liquid, is above these slabs, known as tectonic plates. As a result, tectonic plates continually jostle one another. Likewise, they are capable of sliding over one another, a process known as subduction. The locations on Earth where two plates collide are those where earthquakes are most likely to occur. Faults are the exact surfaces where pieces of Earth slide past one another. Pressure builds up across the boundaries of the plates as they move, holding them in place due to friction. The Earth trembles when the stored energy releases itself, as the former overpowers the latter. These kinds of earthquakes, which include those originating from the East Anatolian Fault in Turkey and the San Andreas Fault in California, are well understood by scientists. The pressure at their margins causes deformations in the center, which allows earthquakes to happen within tectonic plates as well. It is more difficult to identify and quantify these dangers. Professor Greg Barosa of geophysics at Stanford University stated, "Our understanding of these within-plate earthquakes is not as good." According to him, there are fewer warning indicators for earthquakes that happen within tectonic plates than for those that happen near fault lines. The Richter scale is no longer the only available measurement tool. Charles Richter invented the Richter scale in 1935 to quantify earthquakes in Southern California. However, it has now become obsolete. The fact that there is such a significant disparity between the smallest tremors and tower-toppling tremors is taken into consideration by using a logarithmic scale rather than a linear scale. A magnitude 7 earthquake has an intensity that is 10 times greater than a magnitude 6 earthquake and 100 times more than a magnitude 5 earthquake, according to a logarithmic scale. The Richter scale provides approximate estimation of the magnitude of the earthquake by measuring the peak amplitude of seismic waves. If an earthquake is analogous to dropping a rock into a body of water, the Richter scale measures the height of the greatest wave rather than the size of the rock or the size of the ripples. And when there is an earthquake, the waves don't move through a uniform medium like water. Instead, they move through solid rock, which comes in a variety of shapes, sizes, densities, and configurations. Multiple types of waves can also be supported by solid rock. Some geologic features can reduce the force of large earthquakes, while other features can magnify smaller tremors. Although the Richter scale, which was calibrated to Southern California, was useful at the time to compare earthquakes, it only gives a partial picture of dangers and loses accuracy for more powerful events. It also fails to take into account some of the specifics of other earthquake-prone areas across the world, making it of little help to those who are attempting to construct buildings that can resist them. Stephen McCabe, the manager of the National Institute of Standards and Technology's Earthquake Engineering branch, said, "We can't use that in our design calculations. We work with displacements. Another approach to define earthquakes is through displacement, or how much the ground really shifts. The scale of moment magnitude is another. In order to give a trustworthy measurement for comparing seismic events, it takes into consideration various kinds of seismic waves and makes use of more accurate instrumentation and improved computing. Moment magnitude is typically the scale used when discussing an earthquake's magnitude in the news, such as the recent 7.8 magnitude quake in Turkey. The magnitude of the earthquake is still only estimated by this, though. According to Maureen Dinol, an expert in earthquakes at Harvard University, it can take up to a year to determine the scale of an event with only indirect measures. A good example of this is the 2004 Indian Ocean earthquake. She said, "We like to use peak ground acceleration. Engineers have found this metric to be the most useful because it measures how the speed and direction of the ground change. Therefore, earthquake scales have indeed become much more complex and specific throughout time. However, it has also made it possible for scientists and engineers to make far more accurate measurements, which has a significant impact on how they are planned for. They are hard to predict for us in many ways. Since scam artists and pseudoscientists have long claimed to be able to predict earthquakes, forecasting earthquakes is a sensitive subject for scientists. Of course, after closer examination, their claims have faltered. Where earthquakes might occur is something that scientists are quite aware of. They are able to identify prospective seismic hot zones and the types of earthquakes they experience using historical records and geology observations. The exact timing of when the big earthquake will happen is still unknown. That issue has been the focus of decades' worth of investigation by several seismologists. According to Birosa, we are not making immediate seismic predictions. We need to be aware of a variety of things that we don't know, Since the forces that create earthquakes happen gradually over a wide area, yet quickly scatter over a small area, it is challenging to predict when an earthquake will occur. It's incredible how cities may be destroyed in a matter of minutes by forces that have been amassed over several continents over millions of years. It would take years, if not longer, of high-resolution observations conducted deeply underground together with complex models to be able to predict earthquakes. Even so, it's doubtful that it would result in an hour's worth of lead time. As a result, there are eventually too many factors at play and not enough resources to meaningfully evaluate them. Foreshocks can precede a larger earthquake, according to some studies. However, it can be challenging to identify them from the hundreds of smaller earthquakes that happen frequently. The speed of messages and tweets can really outpace that of seismic waves on shorter time scales. For instance, in the Tohoku earthquake that struck Japan in 2011, warnings from close to the epicenter reached Tokyo, which is 232 miles distant, giving locals roughly a minute of warning time. In order to detect earthquakes and provide notifications prior to the ground shaking, many nations are currently putting in place warning systems. This will buy some crucial minutes to find shelter. At the same time, the affected area is frequently shaken by aftershocks following a significant earthquake. If we only had one, Dinol added, we know there will be smaller ones soon. When it comes to making predictions, scientists obviously want to avoid making too optimistic claims that don't pan out, especially when thousands of lives and billions of dollars in damages are on the line. Even this prudence, though, has had negative effects. Following a small series of earthquakes that shook the area in 2009, 6 Italian scientists were sentenced to 6 years in prison in 2012 for accurately stating that the likelihood of a significant earthquake in the town of L'Aquila was minimal. A significant earthquake that killed 309 people hit 6 days after the experts gathered to evaluate the risk. Those convictions were ultimately reversed, and the incident has since served as a case study for how scientists communicate danger and uncertainty to the general population. Sorry, your pets also can't foretell earthquakes. Ancient Greece was the first to record instances of animals behaving strangely before earthquakes. An efficient pattern, however, is still elusive. Every time there is an earthquake, and a cute animal to take pictures of, feathered and furry forecasts appear, although this phenomenon is mostly caused by confirmation bias. Most of the time, animals act strangely, by our standards, but we don't give them any significance until an earthquake occurs. Numerous pets perform actions they have never performed before or afterwards, according to Barroza, who estimated that hundreds of them do so every day. In conclusion, you shouldn't wait for unusual animal behavior to indicate the impending arrival of an earthquake. Undoubtedly, some earthquakes are caused by humans. An earthquake epidemic has been left in the aftermath of hydraulic fracturing's enormous growth across the US. Although millions of gallons of wastewater are injected underground, it is not the fracture of shale rock itself that causes earthquakes. Rocks can more easily move past one another, according to scientists, when water is added. Dinal claimed that by injecting fluid, floors are lubricated. These are referred as induced earthquakes by the US Geological Survey, which also noted that in Oklahoma, the number of earthquakes spiked to 2,500 in 2014, 4,000 in 2015, and 2,500 in 2016. The USGS stated in a release that the decline in 2016 may be partially attributable to injection restrictions implemented by the state officials. Of the earthquakes last year, 21 were stronger than magnitude 4.0 and 3 were stronger than magnitude 5.0. This is more than the 2 earthquakes of magnitude 2.7 or higher that occurred year on average between 1980 and 2000. Barroza asserts that natural earthquakes are not increasing in frequency. Another method that people are triggering earthquakes is by rapidly extracting water from underground reservoirs, according to Dinal. This has been found to induce tremors in cities like Jakarta. There may be a slight impact of climate change on earthquakes. Generally speaking, climate change has had little to no impact on earthquake frequency. However, they are not completely discounting it. Massive ice sheets are melting due to an increase in global temperatures, which releases billions of tons of water from exposed land into the ocean and helps land masses recover. Although no signs have yet shown that global rebalance may have seismic repercussions. There is no proof for this, nor is there any information on which regions of the Earth will exhibit a signal, according to Barroza, who added that what might occur is that enough ice melts that could unload the crust. Although Dinal acknowledged that there might be a mechanism, she believes that the influence of climate change on earthquakes will be relatively minimal. We've improved at lowering the risk of earthquakes and saving lives. The Ring of Fire, a region bordering the Pacific Ocean that includes the Philippines, Japan, Alaska, California, Mexico, and Chile, is where most earthquakes in the world happen, accounting for around 90% of all earthquakes worldwide. In addition, 75% of all active volcanoes are found within the ring. The case study of Mexico is very intriguing. It is seismically active since the nation is perched on top of 3 tectonic plates. The capital was hit by an earthquake in 1985, which resulted in over 10,000 fatalities. Dinal pointed out that any seismic activity poses a risk because the area's geography causes tremors from adjacent locations to be directed toward Mexico City. The ancient Aztec city of Tenochtitlan, an island in the center of a lake, is where the present-day capital of Mexico is located. Shaking from earthquakes is amplified by the dry lake bed, which is now the base of the modern metropolis. The seismic waves from the earthquake in 1985 had a comparatively long duration between peaks and valleys because it started closer to the surface. Skyscrapers start to sway as a result of this low-frequency vibration, claims Dinal. As a result of their greater frequency, the most recent earthquakes were deeper, she explained. Building codes play a significant role in reducing earthquake-related fatalities. Buildings that can move with the earth while still standing can save thousands of lives, but implementing such designs can be expensive and frequently becomes a political issue. The information must ultimately be put into practice, and McCabe noted that new development is a good place to start. Existing structures and older stock are the trickier issue. Countries that are prone to earthquakes are aware of this. Japan has been aggressive in revising its construction codes on a regular basis to resist earthquakes. Despite its shrinking population, Japan has experienced a construction boom in part thanks to the updated requirements. Restrictions for new construction have also increased in Mexico. The capital's soft lake bed soil had to be taken into account, and some movement had to be tolerated, according to laws passed in the wake of the 1985 earthquake. The official construction requirements for earthquake resistance in Iran have undergone multiple revisions in the meanwhile. Likewise, Alaska has spent years creating systems for responding to earthquakes, as well as techniques for reducing damage. The new regulations, however, only apply to brand new structures, and codes are not usually upheld. It appears that the school that was destroyed in the 2017 earthquake in Mexico City had an older structure that was not earthquake-proof. Even some of the structures that withstood the earthquake in 1985 collapsed after shocks in 2017 because the most recent earthquakes in Mexico rocked the ground in a different way. The difference in architectural design between urban and rural areas in nations like Iran is considerable. The majority of people in the country reside in rural areas, where homes are constructed out of more conventional materials like mud bricks and stone rather than reinforced concrete and steel. This is a major factor in the high number of fatalities when earthquakes occur in inaccessible regions of the nation. The nations with the greatest dangers are those that haven't had a significant earthquake in recent memory and, as a result, haven't made preparations for them or don't have the resources to do so. Many of the more than 150,000 fatalities in Haiti as a result of the magnitude 7.0 earthquake in 2010 were caused by a lack of a consistent construction code. One day, the big one is bound to come in the United States. You've been hearing about a really big one, and it is real. The New Yorker was awarded a Pulitzer Prize in 2015 for its reporting on the possibility of a powerful earthquake that would shake the Pacific Northwest. This earthquake, which would be the worst natural disaster in the history of North America, would affect 7 million people and cover a radius of 140,000 square miles. Scientists predict that the San Andreas Fault will produce an earthquake with a maximum magnitude of 8.2, but the prospective quake might reach a magnitude between 8.7 and 9.2, which is larger. Japan, New Zealand, and other regions of the Ring of Fire might expect significant earthquakes as well. We just have an approximate idea of the typical interval between them, which varies from place to region. We don't know when these earthquakes will shake us. That Pacific Northwest scenario has been debated for decades in the industry, according to Barossa. Although I wouldn't say it's overdue, anything can happen at any time. Dinol agreed, saying, "It's a threat. There hasn't been an earthquake there in a long, which translates to more than 300 years, so we tend to overlook the threat. The Pacific Northwest may therefore be caught off guard, even if Catherine Schultz, the author of the New Yorker article, kindly gave a guide to get ready, while California has long been preparing itself for large earthquakes with building rules and disaster preparedness. So, when will it happen again? The best estimate is that earthquakes of the magnitude of 1906 happen every 200 years or so, based on models that account for the San Andreas Fault's long-term rate of slip and the amount of offset that happened on the fault in that earthquake. According to the assessment of the Working Group on California Earthquake Probabilities, there is only a minuscule probability, approximately 2%, that such an earthquake might occur in the next 30 years due to the amount of time required to collect slip equivalent to a 20 feet offset. Over the next 30 years, smaller earthquakes, magnitude about 7, that strike the Hayward Fault, the peninsular segment of the San Andreas Fault, or the Rogers Creek Fault, pose a greater threat to the San Francisco Bay Area than an earthquake of the size of 1906. Quake experts believe that the Hayward Fault, which runs along the East Bay, is the most dangerous fault in America. Despite the fact that the San Andreas line receives most of the attention following the terrible earthquakes of 1906 and 1989. Seismologists warn that it is one of the most active faults and that it most likely will be the cause of the next big one in the San Francisco Bay Area. The Hayward Fault extends through several inhabited areas, including Richmond, El Chorrito, Berkeley, Oakland, San Leandro, Castro Valley, Hayward, Union City, Fremont, and San Jose. This is where the real hazard rests. The Oakland Zoo, Cal's Memorial Stadium, BART rails, and freeways are all in the risk zone, as are houses, schools, churches, and other landmarks. The Hayward Fault, which runs along the border of San Francisco's East Bay that is most densely populated, is being closely watched by scientists. Devastating earthquakes can be generated by the Hayward Fault activity. This 74-mile-long fault is often known as a tectonic time bomb. The Hayward Fault has seen 5 significant earthquakes in total over recorded history, the most recent of which occurred in 1868. The Hayward Fault is often the main concern for scientists making San Francisco earthquake predictions because it is about to experience another significant earthquake. Over 7 million people now call the Bay Area home, and almost 3 million of them reside along the fault. Scientists from the U.S. Geological Survey, USGS, predict that the Hayward Fault will rupture at any moment and that most of the area is still at risk. As Petra Nemcova says, we cannot stop natural disasters, but we can arm ourselves with knowledge. So many lives wouldn't have to be lost if there was enough disaster preparedness. You can suggest topics you want to see next in the comment section below. Please subscribe to Weather Collapse if you want to know more and be updated on the latest news about natural calamities or disasters happening all over the world, and don't forget to like today's video. We'll see you in the next video. Thanks for watching.